In this question, we have a two-way table, and we're told that the following table shows a random sample of 200 adults in a cafe which ordered tea, coffee, or chocolate. And we've been given the gender of those adults. We've been asked to use a chi-squared test with a 5% level of significance to investigate whether there's any association, any link between the type of drink ordered and the gender of the customer. We'll start with the hypotheses. The null hypothesis here is that gender and drink preference are independent to each other. There is no link, there is no association. And the alternate hypothesis is that gender and drink preference are not independent. There is some sort of link to them. There is some sort of association. To begin our investigation, we're going to need, firstly, for this two-way table, for this contingency table, we're going to need some totals. So we're going to need the row totals and the column totals. So we'll start with 99, 73, and 28. Also 94 and 106. Our grand total of 200 should be verifiable two ways, by adding these three red totals from the bottom or by adding the two from the sides. Either way, we should add up to 200 if we've done this all correctly. Using the row and the column totals, we should be able to calculate expected frequencies for each of these cells. The first cell, where we have male customers who ordered tea, we're going to do 99 times 94 divided by 200. That gets us an expected frequency of 46.53. We'll do a similar thing for all of the cells and generate 6 expected frequencies. Just quickly checking all the expecteds to be above 5, and since they are, we can continue. We have enough to think about the critical value. Our significance level is 5%. For our degrees of freedom, we've got 3 minus 1 times 2 minus 1 gives us 2 degrees of freedom. And looking up this critical value, the 5% level of significance, we have 5.991 as our critical value. Anything in this region, this red shaded region, is going to be a significant result and would lead to us rejecting H0. Okay, let's generate the test statistic. I'm going to use the sum of the observed squareds over the expected, and from that we'll subtract the n value. So the fractions that we get here are going to be the black observed frequency squared over the red expected frequency. And we'll do this for all 6 cells, and then we'll minus 200. This leads to a test statistic of 8.912. Is this significant? Looking at the diagram, this is going to lie in the critical region. This is over here. We have a significant result. We have enough evidence to reject H0. Let's just formalize this. So 8.912 is greater than 5.991, significant result, and then our two-part conclusion, as always. Firstly, our mathematical conclusion, there is not enough evidence to reject H0, and then secondly, in context of the question, there is evidence that gender and drink preference are not independent. Now, there does seem to be some link, some association between gender and the drink they prefer to order.